At Subotica railway station in northern Serbia, something remarkable is happening. A sea of people fills the platform, their faces bright with anticipation. Serbian flags wave energetically in the air as the crowd erupts in celebration. The reason for this excitement? A gleaming, state-of-the-art high-speed train is pulling into the station for the very first time. As the modern train glides to a graceful stop, Serbia's president emerges from one of the carriages, his expression radiating pride and accomplishment. He makes a historic announcement that will reshape transportation across the region. From this day forward, traveling from Belgrade to Subotica will no longer take more than 5 hours. The journey will now require just 79 minutes. For the people of Serbia, this moment represents far more than improved transportation infrastructure. It symbolizes a transformation that their parents and grandparents could scarcely have dreamed possible. This cutting-edge, high-speed rail corridor was constructed by a Chinese engineering firm over nearly a decade of intensive work. Perhaps most significantly, it stands as China's inaugural high-speed railway project anywhere on the European continent. When this ambitious undertaking first broke ground, skepticism ran deep. Industry observers across Europe doubted whether Chinese rail technology could ever successfully penetrate the notoriously competitive and regulated European transportation market. In 2017, concerns escalated to such a degree that the European Commission itself launched a formal investigation into the Hungarian portion of the Hungary-Serbia railway corridor, with some officials actively attempting to block the project's advancement. Yet after 8 demanding years filled with technical challenges, regulatory hurdles, and constant scrutiny, the Chinese construction team achieved what many considered impossible. They completed the Serbian segment of the railway to exacting standards and brought it into full commercial operation, proving their capabilities on one of the world's most demanding stages. This achievement raises compelling questions that extend far beyond engineering prowess. What does this railway truly mean for Hungary and Serbia's economic futures? What obstacles did the Chinese team encounter during those 8 years of construction, and how did they overcome resistance from some of Europe's most powerful institutions? And perhaps most intriguingly, what does this breakthrough project signal about the future of infrastructure development across the European continent? Before we dive deeper into this fascinating story, I invite you to subscribe to our channel so you won't miss our upcoming investigations into global infrastructure, economics, and the forces reshaping our interconnected world. The origins: a railway frozen in time. To understand the significance of what has been accomplished, we must first travel back in time and examine what existed before this modern marvel came into being. The story of rail connectivity between Budapest and Belgrade actually stretches back more than a century. The original railway line linking these two important Central European cities was inaugurated in 1882, during an era when steam locomotives represented the pinnacle of transportation technology. For decades, this line served as a vital artery for trade, travel, and communication between Hungary and Serbia. But by the early 21st century, this once proud railway had deteriorated into a shadow of its former self. After more than 140 years of service, the aging infrastructure had become a liability rather than an asset. The steel rails showed severe signs of wear and degradation. The supporting systems, stations, signal equipment, electrical installations, were hopelessly outdated, relics from a bygone era that could barely function in the modern world. The technical limitations were stark and problematic. Nearly 90% of the entire route consisted of single-track sections, meaning trains could only move in one direction at any given time. Trains traveling in opposite directions had to wait at passing points for their counterparts to clear the track. A system that might have been adequate in the 19th century, but was utterly inadequate for 21st century demands. The consequences were predictable and frustrating. Average speeds along the route crawled below 40 kilometers per hour, barely faster than automobile traffic on rural roads. Delays were not occasional inconveniences, but routine occurrences that passengers and freight operators had simply learned to expect. A journey from Budapest to Belgrade, which spans approximately 340 kilometers, required a grueling 8 to 9 hours under optimal conditions, and often considerably longer when maintenance issues or scheduling conflicts arose. For businesses trying to move goods efficiently between the two countries, this decrepit rail link had become an expensive bottleneck. For ordinary citizens hoping to visit family or explore opportunities across the border, the journey was an exhausting ordeal that discouraged travel and limited human connections. By 2013, both nations recognized that the situation had become, well, untenable. The railway that had once symbolized progress and connectivity now represented stagnation and isolation. Hungary and Serbia reached a watershed agreement. They would undertake a comprehensive transformation of the aging corridor, upgrading it into a modern high-speed railway that could compete with the best transportation infrastructure anywhere in Europe. The ambition embedded in this agreement was honestly breathtaking in scope. The proposed modernization would create an entirely new railway spanning approximately 340 kilometers, directly linking Serbia's capital, Belgrade, with Hungary's capital, Budapest. The financial commitment was equally impressive. Initial estimates placed the total investment requirement at roughly $3 billion United States dollars, which is, a massive sum for two countries that were not among Europe's wealthiest nations. More than just laying new track, this project demanded a technological quantum leap. The design specifications called for trains capable of traveling at 200 kilometers per hour, a five-fold increase over the existing infrastructure's performance. This wasn't merely an upgrade, it was a complete reimagining of what rail transportation between these nations could achieve. There was just one significant problem. Neither Hungary nor Serbia possessed the indigenous technical expertise or industrial capacity to execute such an advanced project independently. Their domestic railway industries, while competent at maintaining traditional systems, lacked experience with high-speed rail technology. They would need to look beyond their borders and forge partnerships with nations that had already mastered this demanding engineering discipline. When the tender for this multi-billion-dollar contract was announced to the international construction community, it attracted intense interest from engineering firms across the globe. Companies from Germany, France, Italy, Japan, and South Korea, nations with established high-speed rail pedigrees, submitted elaborate proposals showcasing their technological capabilities and project credentials. The competitive evaluation process stretched across multiple rounds of technical assessments, financial analysis, and capability demonstrations. Then, in 2014, an announcement sent shockwaves through the international infrastructure community. A Chinese company had won the contract. The outcome surprised many Western industry observers and, honestly, sparked considerable controversy. At that time, China's high-speed rail technology, while rapidly advancing, was not yet universally regarded as equivalent to the proven systems developed by Japan, France, or Germany. European competitors questioned how a Chinese firm could prevail in such a prestigious European project. Understanding why Serbia ultimately selected a Chinese partner requires looking beyond superficial assumptions about cost considerations. While competitive pricing certainly played a role, the decision was grounded in more substantive factors that reflected Serbia's national priorities and China's demonstrated capabilities. First and foremost, the Chinese proposal demonstrated technological reliability backed by real-world performance data. By 2014, China had already constructed more high-speed rail track than any other nation on Earth, over 11,000 kilometers at that point, with thousands more under construction. Chinese engineers had confronted and solved problems involving diverse terrain types, extreme climate variations, complex geological conditions, and massive passenger volumes. This wasn't theoretical expertise extracted from textbooks. It was practical knowledge earned through actual project execution at unprecedented scale. For Serbia, this railway represented far more than a transportation upgrade. It was a critical national infrastructure project with implications for economic development, international connectivity, and national prestige. The government established exceptionally rigorous technical standards that any contractor would need to meet. The railway would traverse varied terrain, from flat agricultural plains to more challenging geological formations. It would need to operate reliably through Serbia's cold winters and hot summers. It would need to accommodate both high-speed passenger services and heavy freight traffic. And it would need to integrate seamlessly with European railway systems despite being built to a different development timeline. The Chinese engineering team's proposal demonstrated a thorough understanding of these complex requirements. Their track record showed an ability to deliver large-scale rail projects on schedule and within budget, a claim that European contractors, despite their technological sophistication, could not always match. In recent decades, several high-profile European rail projects had experienced significant delays and cost overruns, eroding confidence in traditional Western approaches. Efficiency represented another crucial differentiator. In November 2013, the Prime Ministers of China, Hungary, and Serbia jointly announced the formal launch of the Railway Initiative. A dedicated trilateral task force was immediately established to coordinate planning, financing, and implementation across the three nations. From this initial announcement to the actual commencement of construction activities took just 3 years, remarkably rapid for a massive cross-border infrastructure undertaking involving multiple governments, regulatory frameworks, and stakeholder groups. For China, the strategic importance of this project extended far beyond the commercial value of a single construction contract. This railway represented an opportunity to establish China's first high-speed rail footprint in Europe, the world's most mature and competitive transportation market. Success here could validate Chinese technology on the global stage and open doors to additional projects across the continent. Failure would be equally visible and damaging to China's international infrastructure ambitions. Understanding these high stakes, Chinese authorities committed exceptional resources to ensure excellence. More than 200 technical specialists and engineers were dispatched to conduct comprehensive on-site surveys and assessments before any construction equipment arrived. China publicly pledged that this line would rank among the finest high-speed railways anywhere in Europe, setting a new benchmark for performance, reliability, and passenger experience. These were not empty promises designed merely to win a contract. They represented a genuine commitment to proving that Chinese engineering could meet and exceed European standards. Facing the European Gauntlet as China's first high-speed railway project in Europe, the Hungary-Serbia corridor immediately became a lightning rod for controversy and skepticism. The welcoming reception that Serbian officials provided did not extend uniformly across the European Union's institutions and member states. Western media coverage of the project ranged from skeptical to openly dismissive. Prominent newspapers and industry publications published analyses questioning whether China could possibly deliver on its ambitious promises. The criticisms followed several recurring themes, each reflecting deeper anxieties about China's growing global infrastructure role. Technical compatibility emerged as a primary concern. Critics argued that Chinese railway technology had been developed within China's domestic context, optimized for Chinese standards, regulations, and operating conditions. Europe's railway systems, by contrast, had evolved over more than a century and a half according to different technical specifications, safety protocols, and interoperability requirements. Could these fundamentally different approaches be reconciled? Many experts expressed serious doubts. Communication and signaling systems presented particular concerns. Modern high-speed railways depend on sophisticated electronic systems that control train movements, manage traffic flow, prevent collisions, and enable speeds that would be impossible with traditional mechanical systems. European certification authorities maintain rigorous testing protocols to ensure these critical safety systems meet exacting standards. Would Chinese systems pass these stringent examinations? The question remained open. But technical concerns represented only part of the challenge. Because Hungary is a full member of the European Union, any major infrastructure project on Hungarian territory must comply with EU regulations, procurement rules, and oversight mechanisms. These requirements exist to ensure fair competition, prevent corruption, maintain environmental standards, and protect the interests of EU member states and citizens. In 2017, tensions reached a critical point. The European Commission, the EU's executive body, launched a formal investigation into the project. The stated basis for this investigation centered on procurement procedures. EU regulations require that major public works projects undergo open, transparent bidding processes that give companies from all member states equal opportunity to compete. Commission officials raised concerns that the Hungary-Serbia railway might have circumvented these requirements. The investigation forced construction on the Hungarian section to halt temporarily, creating uncertainty about the entire project's viability. For nearly 4 years, progress stalled as lawyers, bureaucrats, and politicians debated regulatory compliance issues. It wasn't until October 2021 that substantial forward movement resumed on the Hungarian portion. During this extended pause, virtually every aspect of the project underwent intense scrutiny. Environmental impact assessments were challenged and re-examined. Project transparency and documentation procedures were questioned repeatedly. Equipment procurement contracts were analyzed in minute detail. Financial arrangements were investigated to ensure compliance with EU state aid rules. Each stage of the project that had already been completed and every phase still to come was examined under what felt like a microscopic lens. For the Chinese engineering team, this regulatory gauntlet presented challenges unlike anything they had encountered in previous projects. In China, once a major infrastructure project receives government approval, it generally proceeds with strong institutional support and streamlined coordination. In Europe, the political landscape was fragmented, regulatory requirements were complex and sometimes contradictory, and opposition groups could leverage multiple mechanisms to delay or complicate progress. The technical marathon earning Europe's approval. Recognizing that technical excellence represented their strongest defense against skepticism, the Chinese Engineering Consortium embarked on an intensive campaign to meet and exceed every European standard, no matter how demanding. One of their first major initiatives was establishing a dedicated high-speed rail control systems laboratory in Belgrade, Serbia's capital. This wasn't a token gesture or a temporary facility. It was a substantial, permanent testing and certification center equipped with advanced diagnostic equipment and staffed by specialists who understood both Chinese technology and European requirements. The mission of this laboratory was clear: systematically validate that every critical component of Chinese high-speed rail technology could meet the European Union's technical specifications for interoperability. In practical terms, this meant demonstrating that trains, signaling systems, communication equipment, and safety mechanisms developed in China could integrate seamlessly with the broader European rail network. The scope of this validation work was staggering. Consider just one example: the communication and signaling system that enables trains to operate safely at high speeds. The complete certification process for this single system involved more than 2,000 individual tests, each designed to verify specific functions under various conditions and failure scenarios. Every test had to be documented meticulously, reviewed by independent assessors, and ultimately certified by European regulatory authorities. The Chinese team successfully obtained 71 distinct certifications for core high-speed rail technologies, a remarkable achievement that required years of persistent effort. The list of certified components reads like a technical encyclopedia of modern rail engineering. Catenary suspension systems that supply electrical power to moving trains, turnout monitoring systems that ensure switches operate correctly at high speeds, interlocking control mechanisms that prevent conflicting train movements, centralized dispatching systems that coordinate traffic across the entire network, and electrical power supply equipment capable of delivering stable, high-quality electricity under all operating conditions. Each of these systems represents years of Chinese engineering development, billions of dollars in research and development investment, and the accumulated experience of operating the world's largest high-speed rail network. Now, each had to prove itself worthy of European approval. The successful completion of this certification marathon marked a watershed moment. For the first time in history, Chinese high-speed rail technology had earned what industry insiders began calling an official passport to Europe's heart. The implications extended far beyond this single project. Chinese rail companies could now point to European certification when bidding on projects anywhere in the world, a credential that would prove invaluable in negotiations from Southeast Asia to Latin America. The first triumph, Belgrade to Novi Sad. After years of preparation, regulatory battles, and construction work, the project achieved its first major milestone in March 2022. The Belgrade-Novi Sad section within Serbia officially opened to passenger traffic, and the results immediately validated the years of effort. The transformation was dramatic and visible. Maximum operating speeds increased from the previous 40 to 50 kilometers per hour, barely faster than highway traffic, to a smooth, comfortable 200 kilometers per hour. For passengers, the difference was revolutionary. A journey that previously required more than 90 minutes of rattling along aged track now took approximately 30 minutes in air-conditioned comfort with reliable Wi-Fi connectivity. The operational statistics from the first 3 years of service tell a compelling story about demand and success. The Belgrade-Novi Sad section operates an average of 62 trains per day, demonstrating that the infrastructure can handle intensive service without reliability problems. More than 3.4 million passengers travel this route annually, translating to roughly 12 million total passengers over the 3 years since opening. These aren't merely numbers in a spreadsheet. They represent real people whose lives have been meaningfully changed by improved transportation. Commuters who previously faced exhausting daily journeys now reach their destinations refreshed and with hours of time recovered. Business travelers can make same-day trips that would have previously required overnight stays. Families separated by distance can visit each other more frequently and with far less hassle. The social and economic impacts ripple outward in unexpected ways. Young professionals working in Belgrade can now realistically consider living in Novi Sad, where housing costs are lower and the pace of life is more relaxed. Companies are establishing operations that span both cities, leveraging talent pools that were previously difficult to integrate. Tourism is flowing more freely as residents of each city explore the attractions, restaurants, and cultural offerings of the other. But this successful segment represented only a portion of the complete vision. Much work remained before the full corridor would achieve the transformational impact its planners had envisioned. Completing the Serbian corridor. By October 2025, another major milestone arrived. The Novi Sad Subotica section within Serbia was completed and ceremonially opened to traffic, marking the full operational status of the railway's entire Serbian segment. Serbian President Aleksandar Vučić personally rode the inaugural train and delivered remarks that captured the national pride surrounding this achievement. The era of Serbia's first high-speed railway has arrived. For a country that had endured considerable economic and political challenges over recent decades, this represented a tangible symbol of progress and modernization. The practical benefits for Serbian citizens were immediate and substantial. Travel time between Belgrade and Subotica, a journey that previously consumed more than 5 hours of uncomfortable travel, dropped to just 80 minutes under optimal conditions. Two cities that had been separated by what felt like an insurmountable distance were suddenly connected by fast, reliable, affordable transportation. Meanwhile, work continues on the cross-border section that will directly link Serbia and Hungary. Engineers are conducting joint testing of systems and protocols to ensure seamless operations across the international boundary. Full interconnection is expected to be completed in early 2026, at which point trains will run continuously from Belgrade to Budapest, without requiring passengers to change trains at the border. Once this final connection is established, the complete transformation will be evident. A journey from Belgrade to Budapest that currently requires approximately 9 hours will shrink to just 3 hours. For business relationships, tourism, family connections, and cultural exchange between these nations, the implications are profound. The human dimension, lives transformed. While statistics and engineering achievements tell an important part of this story, the human dimension reveals the project's true significance. Consider the subtle but meaningful changes occurring in cities along the route.